A cyclist starts his ride at point A. He rides 50 kilometers on a bearing 160 degrees to point B, where he rests. After his rest, he rides 42 kilometers on a bearing of 135 degrees to C. We want to find the displacement of C from A. We can draw a diagram to help us with this. He starts at point A and walks 50 kilometers on a bearing of 160 to point B. So if we put point A on our diagram, we need to add a north line so we can do the direction. 160 degrees will be approximately in this direction. The distance is 50 kilometers. This angle is 160 degrees. Remember that bearings are measured clockwise from north. So this would be the point B. From B, he rides 42 kilometers on a bearing of 135 degrees to C. So we need another north line at B. 135 degrees will be approximately in this direction. This is point C. The distance is 42 kilometers. This angle is 135 degrees. And we can complete the diagram by putting on the side AC. The displacement of C from A, we need to give the distance and the bearing. To work out the bearing, we're almost certainly going to need the angle marked. The two north lines, and this angle being 160, tells me that this angle is 20 degrees. Remember that co-interior angles add to 180. So the total angle here is 155 degrees. To find the length D, we're going to use the cosine formula. A squared is B squared plus C squared minus 2BC cos A. If you are unsure about this formula or its use, you can refer to the appropriate section in the core course. Using the formula, D squared will be 50 squared plus 42 squared, take away 2 times 50 times 42 times the cosine of 155 degrees. This calculates to 8070.4 and so on, and taking the square root gives D is 89.835 and so on, or 89.8 kilometers, correct to 3 significant figures. In order to find the angle marked theta, we need to use the sine rule. If you're unsure about the sine rule or its use, you should refer to the appropriate section of the core course. Here we get the sine of theta divided by the side opposite it, the 42, is equal to the sine of 155 degrees divided by the side opposite it, the D, and we'll use 89.84 using one extra significant figure so that we can give our final answer to three significant figures. Sine theta is then 42 times the sine of 155 degrees divided by 89.84. This calculates to give 0.1975, and therefore the angle is going to be the inverse sine or shift sine of this number, which is 11.4 degrees, correct to three significant figures. Remember, that is the angle theta, and we want this angle. So the angle we want is 160 take away theta, which is 148.6 degrees. So our final answer is 89.8 kilometers on a bearing of 148.6 degrees.